Hi everyone, this is Raghavi from CSE-B studying first year first B.Tech in Sri Vishnu Engineering College. This video is made under the guidance of Dr. M. Prasad, Associate Professor, Department of CSE, SPEC Bhimavaram. My topic is Ackermann. What is Ackermann? The Ackermann function is a recursive mathematical function that grows extremely fast. It is often used in computer science to demonstrate the power and limitation of recursion. The function is defined as based on some conditions. Okay, let us see some examples based on this condition in next slide. Okay, let us see an example of a 2, 2. It can result in extremely large number that can be compared in a reasonable amount of time with simple recursion. And Ackermann, it is also used to demonstrate how recursive calls can quickly lead to exponential growth in function evaluation. For example, take a 2, 2. So here we used a condition a of m minus 1 and a of m comma n minus 1. Here both m and n are greater than 0. So we apply the condition and we can solve this. And finally we get 7 is the Ackermann of a 2, 2. So the conclusion, the Ackermann function is a great example of deep recursive and exponential growth in computational complexity. It serves as a tool to study recursive depth, algorithmic limits, and is a key example of functions that grow faster than any primitive recursive function. Okay, let us look into the code. The Ackermann function. The function Ackermann takes two integers parameters m and n. Here we have one base case. If m is 0, the function returns n plus 1. This is the simplest case of the function. And we have two another cases of recursive case 1. If m is greater than 0 and n is 0, the function makes a recursive call with m minus 1 and 1. And recursive case 2, if both m and n are greater than 0, the function first makes a recursive call to compute Ackermann m comma n minus 1 and then uses that result in another recursive call to compute Ackermann m minus 1 and result. Here we have return minus 1. It is a default return. This line should theoretically never be reached due to the nature of the Ackermann function's definition, but it is included to handle unexpected case. Here we have main function int main. So variable declaration m and n are declared as integers to store the user input, and printf statement enter two non-negative integers m and n, and user input, the program promotes the user to enter two non-negative integers, as we know it is the printf statement, and scanf is used to read these values into m and n. And we have to take another printf statement of error. If m and n must be non-negative integers. If the input validation, the program checks if either m or n is negative. If so, it prints an error message and exits the program with a return value of 1 indicating an error. So finally we will get int result Ackermann m comma n. Okay, let us run the code and check the above conditions. So first condition, both m and n are greater than 0. So give 2 and 4. So Ackermann of 2 comma 4 is 11. Check another condition. If m is 0 and n is greater than 0, so 0 and 3, Ackermann of 0 comma 3 is 4. So check another condition. If m is greater than 0 and n is 0, so m 4 and n 0, Ackermann of 4 comma 0 is 13. I hope you understand this program, and thank you.
Hello everyone, my name is Roshni, currently pursuing CSE course in Sri Vishnu Engineering College for Women with hall ticket number 24B01A05B4, and I'm here to tell you about the program how to calculate minimum number of platforms in railway station under the guidance by Dr. Mr. Prasad, Associate Professor, Department of CSE in SWEC Bhimavaram. Here is our problem. It is to calculate the minimum number of platforms required by considering the arrival and departure times of the trains which are arriving and leaving on the same day. You can clearly understand the problem by reading the question displayed on the screen. Now let us see the program. First of all, I had included the header file and written the main function. I had initialized a variable n to input number of trains from the user and a variable I to use in the loop. And I had also declared two arrays of size n to input arrival and departure times of the trains from the user. Now let us see the logic. I had initialized some other variables, plat and max plat, and initialized them with 1, and also initialized I with value 1 and j with value 2. If the arrival time of the next train is less than or equal to the departure time of the before train, then plat is incremented and I is also incremented. Else the arrival time of the second train is greater than departure time of the first train, the plat is decremented and j is incremented. And if the plat value is greater than the max plat is become equal to the plat value. The loop iterates until I and j value becomes n. The value of max plat at the end of the loop will be our required minimum number of platforms. Now let us execute the program and see the output. I am taking number of trains as 6 and their arrival times are 9 o'clock, 9:40, 9:50, 11 o'clock, 3 o'clock and 6 o'clock as given in the question, and the departure times are 9:10, 12, 11:20, 11:30, 7 o'clock and 8 o'clock. Now let us see the output. By using our program, the number of minimum platforms is equal to the 3. Now let us see another output. Here the number of trains are 3 which are mentioned in the question. The arrival times are 9 o'clock, 11 o'clock and 12:35, and the departure times are 10 o'clock, 12 and 12:40. The minimum number of platforms are 1. Thank you.